Hi there. In this video, we're going to be looking at function transformations. So we're going to be starting with a function, and we're going to be transforming it into a new function. And we're going to be relating this to its graph. So if I take the expression for a function and change it a little bit, I want to know what happens to the graph. What can I expect the graph of the new function would look like? This will help us graph things because that means we don't have to start from scratch. And vice versa, we can start with the graph, shift it around, transform the picture, and then ask, well, what happened to the expression of the function? So let's take a look at some pictures. Okay, so here we see the graph of a function. Now, the transformations that we're going to talk about in this video fall into four types. Okay, so to talk about the first type, what I'm going to do is I'm going to duplicate this graph. So I'm going to draw a red function exactly on top of the blue function. All right, and now what I'm going to do is I'm going to apply what's called a vertical shift. A vertical shift, as we can see, is going to move the graph of the original function up or down. Right? So a vertical shift by varying amounts will shift that original graph in the vertical direction. So vertical shift is the first type of transformation that we'll talk about. The second type of transformation we'll talk about is the horizontal shift. The horizontal shift will result in shifting the graph of the function left or right. The third type of transformation that we'll talk about is called the vertical stretch. You can see I can stretch this graph vertically. Or if I stretch it by a factor less than 1, it actually gets squished. And if I go very far, it actually gets inverted. So this is the vertical stretch or vertical scaling of a function. And the fourth type of transformation that we'll talk about is the horizontal stretch or horizontal scaling. And you can see I can end up squishing the function, or I can spread it out horizontally, and it has the same property as the vertical one, where if I go very far, it actually gets inverted. So these are the four different types of transformations that we'll be looking at: a vertical shift, a horizontal shift, a vertical stretch, and a horizontal stretch. Okay, so let's think about this vertical shift. How is this going to happen to the graph? Well, if I think about it, the height of a graph, the position of the graph in the vertical direction, is given by the value of the function. That's how a graph is made. And so if I want to shift a graph upwards, all I have to do is add a positive number to the function. So for instance, if I want to shift this blue graph up 1 unit, I will just add 1 to my function. If I want to shift it up 2 units, I will just add 2 to my original function. If I want to shift it up -1 units, I'll add -1 to my original function. And you can see that's the same thing as just subtracting 1 from a function. So by adding a value to a function or subtracting a value from a function, I can shift the graph up or down. The vertical shift of a function is obtained by computing f of x plus k, where k is the amount of the vertical shift. So now let's talk about the horizontal shift. The horizontal shift is just as simple as the vertical shift, except it's a little bit trickier to think about. So let's think about what we did with the vertical shift. The vertical shift shifted the graph up or down, and we did that by adding a value to the value of the function. We added a number on the outside of the function. Why does that work? Well, because the values of the function are on the y-axis. So by adding a number, we're shifting the graph in the direction of the y-axis, which is up or down. So if we want to slide the graph left or right, then what we want to do is we want to actually shift the direction of the graph in the x direction, which means we want to add or subtract a value from the x. Let's talk about how to get the graph of the red function from the graph of the blue function. Well, the value of the red function at 2 is the same as the value of the blue function at -1. That's 3 less than 2. The value of the red function at 3 is the value of the blue function at 0. That's 3 minus 1, 2, 3. The value of the red function at 4 is the same as the value of the blue function at 1. That's 4 minus 1, 2, 3. In other words, the value of the red function at any number x is the value of the blue function, the original function, at x minus 3. So to shift a graph 3 units to the right, we evaluate the function at x minus 3. Now what if I wanted to shift a graph 2 units to the right? Well, I would evaluate the original function at x minus 2. What if I wanted to shift the graph of the original function 3 units to the left? Well, then I would evaluate the function at x minus negative 3, or in other words, x plus 3. So the rule is the horizontal shift of a function is obtained by evaluating the function at x minus h. That will shift the graph h units to the right. If h is negative, it will result in the graph actually shifting to the left. Okay, so now let's talk about a vertical stretch. Notice what's happening here. The y-coordinates of the points on this blue graph have been scaled by some factor. In this case, we're looking at 4, a factor of 4. And so every y-coordinate has been scaled to 4 times its original amount. Now the y values are given by f of x, so we're really just scaling f of x by 4. So it's 4 times f of x. If I want to scale things by a factor of 3, it would be 3 times f of x. 2, it would be 2 times f of x. If I want to introduce a squish to take it to a half of its original value, it would be 0.5 or 1/2 times f of x. Now we can also scale with a negative factor. So if I put in negative 2 times f of x, I get something that has been flipped and scaled, because when I negate a y value, it goes to the other side of the y-axis. So this is negative 2 times f of x. We see negative 3 times f of x. Negative 1 times f of x, or just negative f of x, is the exact same function that we had before, but flipped vertically upside down. So we have a vertical flip by using the scale factor negative 1. But in summary, to obtain a vertical stretch of a graph, we simply compute a times f of x, where a is the scale factor. Now let's talk about a horizontal stretch. A horizontal stretch is scaling the points in the horizontal direction. Well, notice that the y-coordinates of the points are remaining the same. It's only the x-coordinates that are being affected. So we're really just scaling the x-coordinates by some factor, say b. So let's look at what happened here. The value of the new function, the red function at 2, is the value of the original function at 1. 1 is 2 times a half. The value of the new function at 1 is the same as the value of the original function at a half. 1/2 is 1 times a half. Here, the factor that we're multiplying by is a half. And look at the effect that it has. By multiplying the x by a half, we actually stretched the function out by a factor of 2. What if I were to multiply the x by a third? Well, now I've stretched out the graph by a factor of 3. And if I multiplied the x by a fourth, well, now I've stretched out the function by a factor of 4. Okay, so we see that when the number b is less than 1, we actually get a stretching out. What if the number b is greater than 1? What if I make b equal to 2? Well, now it actually results in a squish. And it's squished by a factor of 1/2. If I make b equal to 3, it's squished by a factor of 1/3. If I make b equal to 4, it's squished by a factor of 1/4. So the stretching actually occurs at a factor of 1/b. Now what if I make b negative? When b becomes negative, here we go up, we flip things around. Just like we saw with the vertical scaling or vertical stretching, when we go to the negative side, it actually results in a flip of the graph in that corresponding direction, in this case, the horizontal direction. But in summary, to obtain a horizontal stretching of a graph, we evaluate f of b times x, where 1 over b is the factor that stretches the graph in the horizontal direction. Okay, so let's get some practice here. First of all, I'm going to tell you the expression for this function. This function is given by x minus x cubed. Okay, so now what we're going to do is we're going to apply a couple of transformations to this function and see if we can figure out the expression of the resulting function. So let me create the transformed function. The first thing we're going to do is we're going to scale this function horizontally by a factor of 3. All right, so there we have it. Now what we're going to do is we're going to shift it vertically 2 units. So here we go. Okay, so there's our new function. So my question here is, what's the expression for this new red function? Okay, well, what did we do first? We scaled it horizontally. Well, we know a horizontal stretch is given by multiplying the x by a factor. And the factor is actually the reciprocal of how much we stretched it. So we stretched it by a factor of 3, which means we're multiplying the x by 1/3. Next, we shifted the function up 2 units. Well, we know a vertical shift is given by adding a number to the outside of the function. And how much did we shift it? We shifted it 2 units. So we add 2 on the outside. And so this is the expression for the resulting red function.